Today I want to go over the simplest relational model that really has any value. And it's really only made up of one table and one relationship. So the entity, hang on, let's back up a second. So I told you tables and relationships, and I immediately start up with this entity thing. What the heck is an entity? Well, in modeling, there are three general layers: the conceptual layer, the logical layer, and the physical layer. And I don't want to get into a deep explanation of what those things are and everything like that, but suffice it to say that in the logical side, you have entities and attributes, and that would roughly equate to tables and columns in the physical side. So today, let's look at the simplest model, and that is one table, one relationship on the physical side. Let's get into it. All right, I'm going to start with a entity and then a relationship. And what kind of relationship can I make? Not an identifying relationship, because that would require a record in the other table. And since we only have one table, you'd never be able to insert the first row. Now this one, the non-identifying mandatory relationship, well, I'm not sure how that would work either, because that would have to be not null. Okay, well, let's just pick this one, the optional relationship, which allows it to be null. So I'm going to pick my entity and my child. Okay, so there I have a conceptual model. Now we're going to call this link, and we're going to now add a column to it, because right now this is perfectly good as a conceptual model. It shows something that could be considered a chain, maybe, but without any keys, and specifically a key column, you can't have a table, really. If you don't have any columns in the table, it doesn't exist. If you don't have a key, you can't address the rows individually. So we're going to need a key column. So let's add one. I'm going to call this link identifier, and I'm just going to make this, whoops, because I don't have any. All right, so that is an integer. I'm going to make it an identity column, and I'm add it to the primary key. Okay, so now this is going to have a column. It's going to be an integer. It's going to be an identifying key column. Oh, and now for this recursive relationship, I have to give the child the column in the child table a name, which has to be different from the parent. And I'm going to call this child link identifier, or child link ID for short. Okay, and now we have not just a conceptual model, we now have a logical model that has an identity column and then a link to the child record. All right, now I'm going to go and make a new physical model to show you what that will look like. And I'm just going to call this MSSQL with a model name. I'm going to skip a bunch of things you could do. But let's look at this. Now we have this child model, physical model, and this, I want to have a constraint name here so it's specific. And I'm going to call this FK child and link. Okay, so the link as the child links to the link parent, or the link parent has the child ID in it. But in order to actually make this a table, you must have a name for that constraint, although it will name it sys something if you don't. But I like to have things specific. So now you have the most basic model imaginable. Now, there's a couple things about this that we've seen, and the most important is the relationship. And this relationship has to be a particular type and a particular uh, foreign key relationship to enforce that it does exist in the table. Otherwise, you can end up with sort of lots of different failures, referential integrity problems, or whatever. Now, what this does is it allows you to have a chain, parent, child, 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 but it doesn't prevent other chains from hooking to your chain. So this would actually look like an upside down tree, basically, where the parents could hook to child, but the child is not uniquely defined, so that it's not enforcing that chains don't run into each other. It also doesn't enforce a feedback loop, right? So now I could have a child and have that child point to its parent, and in making a circular chain. So if you want to have those kind of characteristics, well, those are going to have to be defined elsewhere or in addition to what I've done here. But let's just do this, and let's look at the DDL. So this is what the DDL looks like for this table when it gets created. Identity, child ID. Okay, so I've got this here, PK2. Well, I think I'd like to have that one be a little more specific than that as well. So let's go to indexes and we'll rename that as PK. Ooh, come on, fingers. All right, now I have everything sort of defined the way I like it, and this model is now more or less complete. Now, I didn't give any definition or anything like that, which is good modeling practice, but this is just to illustrate how to make a simple, logical, conceptual, physical model all in one, just with one table and a relationship to itself. Thanks for watching.